Hello, dear friends. In last video, we have seen pressure measurement part 1. Different sensors used for the measurement of pressure and their characteristics and operations like bellows and other sensors, diaphragm, bellows, etc. Today we will continue this measurement of pressure and we will finish this part measurement of pressure today itself. I am here, Lalit Kumar P. Bhaiya, Associate Professor, Electronics and Telecommunication Engineering Department, Bharati College of Engineering and Technology, Durg. Let us see what we have seen in the last video. We have gone through what is pressure, why do we measure pressure, what are the types of pressure like atmospheric pressure, gauge pressure, vacuum pressure, absolute pressure, differential pressure, static pressure and dynamic pressure. Later on we have also seen what are the types of pressure measurement, out of which we have seen this liquid column method, that is manometer type method, and we have gone through this diagram. Manometer, liquid level pressure, changes the liquid level and we can measure on the measuring scale. What is pressure that we have seen? That is force upon area, and the unit of the pressure is Pascal, kilopascal. 1 bar is equal to 100 kilopascal. Then sensing elements, different types of sensing elements to sense the pressure are the Burden tubes, C-shaped Burden tube and helical Burden tube, flat diaphragms, convoluted diaphragm, then one capsule, and the set of bellows which we have seen. These are the various sensors. This is C-type Burden tube, helical Burden tube. This is the diaphragms, and these are the bellows, which we have already seen in the previous video. And then operation of the bellows as well as operation of the Burden tube. How the pressure goes through the inlet and how expansion of the bellows and Burden tube, that we have seen. The motion is then proportional to the pressure applied. This we have seen regarding bellows. Here the operation is given for the bellows with the input pressure, and this is the typical diagram of the bellows which we have seen, consisting pressure input, bellows, spring inside the bellows, and mechanical linkage for the movement of the needle pointer. And then we have seen this Burden tube. Once again I will go through this. A Burden gauge uses a coil tube. This is coil shaped, which as it expands due to pressure increase causes a rotation of an arm connected to the tube. This is the tube here and this is the arm connected here. So due to this pressure, this arm will move, rotation of an arm connected to this tube. Burden are often used in harsh environment and high pressure, but can also be used for very low pressure. The response time, however, is slower than the bellows and diaphragm. This is C-type burden tube, which is shown here. C-type burden tube, and this is movement. Yesterday we have, before this we have seen this one. C-type burden tube, the PSI range as low as 0 to 15 PSI up to 0 to 1500 PSI, and the helical burden tube uses for the pressure range as low as 0 to 200 PSI up to 0 to 6000 PSI, and the spiral burden tube range as low as 0 to 10 PSI up to 0 to 100,000 PSI. You can see this one. This is the C-type burden tube. This is the figure for the C-type burden tube, and this is mechanical linkage with the burden tube. This is the spiral type burden tube. You can see this is spiral nature is there, and this is mechanical movement, and this is the inlet for the pressure. Here is the inlet for the pressure, and this is the helical type burden tube. The process pressure here, and this is the moving tip by which we can measure the pressure. So these are the three ranges of the burden tube: C-type burden tube, spiral burden tube, and helical burden tube. And the range of the pressure for these three is already given here: C-type burden tube, helical burden tube, and spiral burden tube. Burden tube pressure gauge. For the measurement of the pressure with the help of burden tube, we use the gauge also. Principle: the burden tube works on simple principle that a bent tube will change its shape. After applying the pressure, the tube will be bent at the end. That will change its shape. As pressure is applied internally, the tube strengthens and returns to its original form when the pressure is released. Once the pressure is applied, the tube strengthens. After strengthens and measurement, the pressure after the pressure release, it comes to its original position. The tip of the tube moves with the internal pressure. The tip of the tube moves with the internal pressure change and easily converted with a pointer onto a scale. So whatever pressure we apply, the tip of the burden tube will change, and that will cause the pointer to move for the measurement of the pressure. This is gauge. So this is the operation. Then advantages of burden pressure gauge: low cost and simple construction. Wide variety of ranges are available. High accuracy. These are the advantages of the burden tube. Disadvantages of burden pressure gauge are low spring gradient, because a spring used along with the tube for the mechanical movement also, and susceptibility to hysteresis, shock and vibrations. Due to high pressure, there may be a vibration or shocks. So it has a susceptibility to hysteresis, shock and vibrations. Then the next sensing element for the pressure measurement is the diaphragm. A diaphragm is a circular shaped convoluted membrane that is attached to the pressure fixture around the circumference. Around the circumference. And you have already seen the diaphragm. You have already seen the speakers and microphones where diaphragms are used for the air pressure. So a diaphragm is a circular shape convoluted membrane that is attached to the pressure fixture around the circumference. The pressure medium is on one side and the indication medium is on other side. Diaphragm provides fast acting and accurate pressure indication. However, the movement or stroke is not as large as the bellows. This is the difference between bellows and diaphragm. You can see this figure. This is the diaphragm figure here. This is the fixed membrane and pressure inlet is here, and there is a movement of this diaphragm. With this movement, this header will change its position, and this change in position, displacement will converted into pressure. This is another type of diaphragm used here. This type of diaphragm is also used in the speakers, and you can see these are the various types of the diaphragm. This is convex diaphragm capsule, this one, and the motion will give this type of vibration. Then nested diaphragm capsule. This shape is a nested type. This will provide the motion. And this is corrugated single multiple capsule element diaphragm. Corrugated single multiple capsule. This one. And here is a motion. This is free end. And here is a spacers, spaces, space is shown here, and this is fixed end. So these are the different types of the diaphragm which can be used for the pressure measurement. Diaphragm gauge of pressure measurement. Like we have seen the pressure gauge for the measurement of the pressure in case of the bellows as well as in case of the another pressure measurement elements. Similarly, we will see the pressure gauge in diaphragm called as the diaphragm gauge of pressure measurement. The diaphragm is a flexible disc which can be either flat or with concentric corrugations and is made from sheet metal with a high tolerance dimensions. The diaphragm can be used as a means of isolating the process fluids or for high pressure applications. It is also useful in providing pressure measurement with electrical transducers like LVDT, linear variable differential transformer. It is used as primary pressure transducers in many dynamic pressure measurement devices. In many devices, these diaphragms are used. I have already told you. In speakers, these diaphragms are used, and you know very well about the speakers diaphragm and how the electrical pressure is converted into sound. There are two different devices that are referred to as capsule. The first is shown in figure. This figure, this is a capsule type diaphragm. Here pressure inlet, and here you will get the outlet. The pressure is applied to the inside of the capsule, and if it is fixed only at the air inlet, it can expand like a balloon. This arrangement is not much different from the diaphragm, except that it expands both ways. The capsule consists of a two circular shaped convoluted membranes, usually stainless steel, sealed tight around the circumference. The pressure acts on the inside of the capsule, and the generated stroke movement is shown by the direction of the arrow here. This is stroke movement shown here, and this is capsule type shape. Pressure goes inside and it will fill up by the pressure, and movement will be there. It will expand like a balloon, and this tip will move to the forward. The second type of capsule is like the one shown in the differential pressure transmitter. The capsule in the bottom is constructed with two diaphragms. This is another type of capsule, diaphragm capsule. Here differential pressure is used. Two types of diaphragms are used in this, forming an outer case, and the interspace is filled with viscous oil pressure. Viscous oil pressure is applied to both sides of the diaphragm, and it will deflect towards the lower pressure. So in second type of this diaphragm capsule, a viscous medium is used, and using this viscosity medium, the differential pressure can be measured. So this is about the diaphragms, measurement of the pressure using the diaphragm. Its advantages and applications. It is used for the measurement of extremely low pressure, vacuum or differential pressure. They are commonly used in very corrosive environments. Their advantages are it is very sensitive, and they can measure fractional pressure differences over a very minute range, and they only needs less space. Then electric method for the measurement of the pressure is the strain gauge pressure transducer. This is passive type resistance pressure transducer, and it is electrical resistance will change when it is stretched or compressed. So this is about the strain gauge. If the pressure is applied on the strain gauge, it will be stretched or compressed, and its resistance will change. Then this resistance will be calibrated in terms of the voltage, and that will be in terms of pressure then. A strain gauge is a wire which will change its resistance when mechanically strained due to physical effects. Strain gauge is connected to the diaphragm, and when the diaphragm flexes due to the applied pressure, the strain gauge will stretch or compress, and because of this variation in its cross-sectional areas, and its resistance will change due to this, and this change is converted into voltage by linking 2 or 4 similar gauges similar to Wheatstone bridge, so that output can be maximized and reduces sensitivity to errors. So what is strain gauge? Strain gauge is simply a wire of which resistance changes due to the pressure on this wire connected with the diaphragm. And once this pressure is there, there will be a change in the resistance of this wire, that is strain gauge. And this strain gauge may be in the Whetstone bridge, or out of 4 arms, 1 arm will with this bridge, and pressure is applied to this arm particularly. And hence, there will be unbalance in the bridge and causes the change in voltage. That will be measurement of the pressure, calibrated in terms of pressure. Advantages of strain gauges: strain gauge pressure transducer, simple to maintain and easy to install, good accuracy and stability, fast speed of response, wide range of measurements, no moving parts and high output signal strength over a range of capacity. Disadvantage of strain gauge pressure transducer: temperature compensation and constant voltage supply is needed. When we use the strain gauge into a bridge, one of the arm of the bridge, then we need the temperature compensation of the circuit, and we require the constant supply voltage. Otherwise, there will be a change in the measurement of the pressure. The electrical readout is necessary. So this is about the pressure transducer called as the strain gauge, electric transducer. Then piezoelectric pressure transducer. Piezoelectricity is the ability of some materials, mostly crystals, to generate an electric potential in response to applied mechanical stress. You have already heard about, I think, piezoelectric crystal. In similar type, this transducer is there for the measurement of the pressure. In this transducer, the piezoelectric effect is used in certain material such as quartz to generate rapid electrical signals and measuring the strain upon the sensing mechanism due to pressure. Common types of piezoelectric pressure transducers are charge mode type and low impedance voltage mode type. These are the two types of commonly used piezoelectric pressure transducers: charge mode type and low impedance voltage mode type. It has a good frequency response and no need for external power because it is like a crystal. And it has a disadvantages: changes in temperature will affect the output, and it cannot measure static pressure. After this, piezoresistive transducers are there for the measurement of pressure. Piezoresistivity is the change in material's resistance because of a change in stress in the material. Piezoresistive gauge factor decreases as temperature increases. A transducer which uses this effect is a silicon-based MEMS pressure sensor, and it has various applications like blood pressure sensing and tire pressure sensing. These are the two applications of this piezoresistive sensor. So dear students, kindly go through all these details of the pressure measurement, various sensors, its uses and application, etc., operation, diagrams. Next time we will see the another article. Thank you very much for listening this video. Thanks to all. Go through your classroom and see your test questions and to try to solve the test paper and make its PDF and post it on your classroom. Thank you very much. Thanks a lot.